Hello friends, welcome to my YouTube channel RF Design Basics. In this video, I am going to explain the die-set matrix and its application. For this, I have taken a simple network in which we have a 1 volt source and few resistors. So first of all, we will try to find out what will be the die-set matrix. For that, we need to convert this into graph. So to convert it into graph, we need to identify nodes where more than 2 branches are connected. So if I see here, there is more than 2 branch. So I will call this as node 1. Then if you look here, here also you have first, second and third, more than 3 branch connected. So I will call this as node 2. And here we have 3 branches connected, so this is node 3 and this is node 4. So we have totally 4 nodes in this graph. Now let us highlight the branches. So first branch will be this branch, then second branch we can take as this 5 ohm, third branch I can take this 5 ohm, so this is third branch, then I can take 10 ohm, 10 ohm and 10 ohm as 4, 5 and 6 branch. So let us draw these 4 nodes and try to convert it into the graphical form. So these are the 4 nodes. I will call these nodes as node 1 here, node 4 here, node 2 here and node 3 here. Now let us connect this. So we have connection between node 1 and node 4. So here it is node 1 and node 4. Then 4 and 2 is also connected, 4 and 2. Then 1 and 2 is connected, node 1 and 2. So node 1 and 2. Then node 3 and 4, 1 and 3 and 2 and 3. So 3 is connected with all other nodes. So 3 is in the middle. So we can make it like this. Now let us assume the direction of current here. So direction of current we can assume by ourselves. Let's say this is the direction of current in branch number 1. Then we have branch number 2. We have direction like this. This is just assumption, you can assume anything. Then branch number 3 I am taking like this. And branch number 4 will be here. So this is branch number 4. I am taking this as outgoing. So this is branch number 4. Then branch number 5 also I am taking outgoing 5, and branch number 6 is also outgoing. Now to find out the loop currents, we need to apply the die-set matrix. And for die-set matrix, first of all we will take a tree from this. I hope you are already aware of tree. Tree is any graph which is connected to all the nodes and there is no loop forming. Now I have copied and pasted the graph here, and I am going to take the tree as 4, 5, 6. So remaining 1, 2, 3 branch will act as link. So I'll just make it look like link by erasing some portion so that it will become a dotted line. So this is a dotted line. Now we can see there are totally 3 loops where this is loop 1, this is loop 2, and this is loop 3. So I have taken the names of loop as per the link name. So here link is link number 1, link number 2, and link number 3. So to write the tie-set matrix, we will be taking these loop currents in the left hand side as I1, I2, and I3, where I1 is loop current here, I1. Similarly, loop current here is I2 and loop current here is I3. And then we will see how many are along the direction of this link and how many are opposite to this direction. So if it is in the direction, we will take them positive. In the top, we have branches 1, 2, 3, 4, 5, 6. So these are our branches. So let's take all the values. So when I am moving in loop 1, branch number 1 is in the same direction as link. So it is a link. Then this tree branch is opposite to this direction. So at 1 I will write +1, but at 5 I will write -1. Then this loop completes with the fourth branch, which is in the same direction of the loop. So I will take +1 over here. This is the fourth branch. Then go to the loop 2. In loop 2, it is made of 2, 5, and 6, where 5, 2 is in same direction, 6 is in opposite direction. So I'll take 2 and 5 as +1, 2 is +1, 5 as +1, and 6 as -1. Remaining terms are 0. Here also remaining terms are 0. Then loop 3 is consist of 3, 4, and 6. So 3, 4, and 6, where 3 is in the same direction because it's a link, 4 is in opposite, 6 is in same direction. So 6 will be +1, 3 will be also +1, and 4 will be -1. 0, 0, 0. So we got the tie-set matrix. This is called tie-set matrix of this network by considering tree as 4, 5, and 6. If we consider these twigs, this will become the tie-set matrix. Now what are the information we get from this matrix? The first information we get is the addition of all the columns will give you the branch current. So if I am going to add the first column, it will give you the branch current in first branch. That means J1 will be equal to I1 +0 +0. Similarly, J2 will be equal to I2. Then J3 will be equal to I3. Now the remaining one, J4, branch current in the fourth branch will be I1 minus I3. I1 minus I3. Branch current in fifth one will be minus I1 plus I2. Then branch current in sixth one will be equal to minus I2 plus I3. So minus I2 plus I3, and this information can be verified here also. So if I want to look into branch 4, current I1 and then I3 is opposite. So in this direction current is I1 minus I3. We can verify here. So like that, if you want, you can verify here to see the correctness of tie-set matrix. So apart from this, what other information we get is, if I add each of the row, I will get V1 then plus V4 plus minus V5 equal to 0. Then if I go for second row, it will give you V2 plus V5 minus V6 equal to 0. Similarly, the third row will give V3 minus V4 plus V6 equal to 0. So these informations we can apply by calculating separately these voltages. So let's write the voltages. What will be V1? V1 will be equal to voltage across this 1 and 4, branch number 1, voltage across branch number 1, which is given as the current through this, that means I1 into 5 and 1 volt lesser than that, so minus 1. So you can write 5I1 minus 1, 5I1 minus 1. Then V2 will be equal to, V2 is branch number 2, so branch number 2 we have a 5 ohm resistor and current flowing is I2, so it is 5I2. And V3 will be equal to, V3 is voltage across branch number 3, so branch number 3 is consist of a 5 ohm resistor, so it can be written as 5I3. Similarly V4 is branch number 4 here and branch number 4 here is this 10 ohm, so I can write 10 into J4, which is 10, and what is J4? I1 minus I3. Then V5 is again 10 ohm. All these 4th, 5th and 6th is 10 ohm, so I can simply write 10 J5, which is 10 into J5 is minus I1 plus I2, and V6 is 10 J6 equal to 10 into minus I2 plus I3. So we got all the voltages in terms of loop current. So V1 we could have written in terms of J as J1 R1. So if you see that, it will be 5I1 minus 1, and same way we can write. Now we will use these equations V1 plus V4 minus V5 equal to 0 to write three different equations. So if I write V1 plus V4 minus V5, we will get the first equation. So equation 1 is V1 plus V4 minus V5 equal to 0. So V1 is 5I1 minus 1, V4 is 10I1 minus 10I3 minus V5, so minus plus 10I1 minus 10I2 equal to 0. We can combine all the I1 together, so 10I1, 5I1, 25I1 minus 10I2, then minus 10I3 equal to 1. So this is our equation number 1. Now equation 2 we are going to form equation 2. For equation 2 we need V2 plus V5 minus V6 is 0. V2 plus V5 minus V6 equal to 0. V2 is 5I2 plus V5. V5 is 10 minus I1, so minus I1 plus I2, so minus V6, so minus 10 into minus I2 plus I3 equal to 0. So we can combine all the I1, so here minus 10 I1, so it is minus 10 I1, then I2 is plus 10 I2 here, plus 10 I2 here, and 5 I2 here, so plus 25 I2. Then I3 we have minus 10I3, minus 10I3 equal to 0. Similarly, the equation 3 can be formed using V3 minus V4 plus V6 equal to 0. So V3 minus V4 plus V6 equal to 0. This gives us V3 5I3 minus V4 is minus 10I3 minus 10I1 plus 10I3, then plus V6. So plus V6 is minus 10I2 plus 10I3 equal to 0, which is equal to, we have 5I3, 10I3 and 10I3, so 25I3, then minus 10I2 and minus 10I1 equal to 0. So this is equation number 3 and this was our equation 2, and we can write all of them in a matrix form and solve them. So 25 minus 10 minus 10. First we write 25 minus 10 minus 10. Second one is minus 10, 25 minus 10, and third equation is minus 10 and 25 into I1, I2, I3 equal to 1 0 0. So after solving this equation we get I1 equal to 0.0857, I2 equal to 0.057 and I3 as 0.057 amps. So these are loop currents. If you are interested to find branch currents, we can find the branch currents using these values which we have already written above, like J1 will be I1, J2 will be I2, J3 will be I3. So J1 is 0.0857 amps, J2 is 0.057 amps, J3 is 0.057 amps, and I1 minus I3 is J4. So J4 is I1 minus I3, so I1 minus I3 will be equal to 0.0857 minus 0.057 amps. J5 equal to minus I1 plus I2. So minus I1 is 0.057 minus 0.0857 amps. Then J6, current in branch 6 is minus I2 plus I3. So if I take minus I2 plus I3, it will become 0. That's all. This is how you apply the Tysett matrix for solving a problem. Thank you.